All right, so I'm making this video about multiplying fractions. This is a continuation of our topic on dealing with fractions. All right, multiplying fractions is very easy for the most part, as long as you know how to deal with bigger fractions as you go along. All right, so let's say we have 2/9 times 3/8. All right. A lot of students will just look at this and then they'll multiply the top to the top and then bottom to top to bottom. 72, 6/72. Right. This is correct, but normally you will have to simplify this, right, by looking for the common factors in the numerator and the denominator. Right? Here we know from our times table, 6 is a factor of 72. So 6 goes into 6 is 1. 6 goes into 72 is 12. So our final answer is 1/12. Now, you can arrive at this same 1/12 by just looking at the numbers. In multiplication, everything in the numerator is being divided by everything in the denominator, right? It doesn't matter which one you look at. So what you do is you just look for common factors between the numerators and the denominators. What I mean to say is, let's say I see a 2 here, I see an 8 here in the denominator of the second fraction. I see a relationship, right? I see 8 is what? 2 times 4. So basically, if I divide this by 2, I'll get 4 here. If I divide this by 2, I'll get 1 here. That's allowed, right? Because multiplication is commutative, meaning you can switch these numbers around because they are multiplying, right? And then when I look at 3 and then look at 9, I see a relationship, right? I can divide 9 by 3. So divide this, 3 by 3, you get 1. 9 by 3, you get a 3, right? So after that, you just multiply the numbers in the numerator and then multiply the numbers in the denominator separately. So if we do that, 1 times 1 is what? Is equal to 1. And then 3 times 4 is equal to 12. And the reason this approach is good is if you happen to have larger fractions, right? You don't want to multiply and then get large numbers that, are difficult to deal with, right? So simplify as you go, right? By using common factors between the numerators and the denominators. All right, let me give another example. Let's say I have 5/12 multiplied by 21/25 as an example, right? So as soon as you see this, you look at the numerators, you look at the denominators, right? Just using eye coordination, you know there's a relationship between 5 and 25, right? Because 25 is what? 5 times 5. So it means we can do something over there. So 5 into 5 is 1. 5 into 25 is 5. And then we look at 21 and 12. Do we see any relationship? Now we can see there's a 3, right? 3 is a common factor between these two, meaning that 3 can divide each of them, right? And there will be no remainder. So we divide this by 12 by 3, we get a 4. And then 21 by 3, we get a 7, right? So now we can write out our final result. Remember, we're multiplying only the ones that are not crossed out, right? So it's 1 times 7, which is 7, and then 4 times 5, which is 20. All right? So this is the idea behind simplifying as you go. Let's do another one. Let's say we have 12 over 15 multiplied by 35 over 42, right? And you notice that if you are to multiply the numerators, you get a huge number, and then denominator you get another huge number, and then after that you have to come back and simplify. That will be, you know, very cumbersome. So just use this approach, right? So you look at the numbers, numerator against denominator, any which way. Don't worry about where it is in the numerator, right? So we look at these two, 12 and 15, there's a relationship. I see 3 can divide each of them. So 3 into 12 is what? 4. 3 into 5 is 5. So we're done with that over there. And now as soon as I wrote 5, I noticed there's a relationship between 5 and 35, right? Right? 35 can be divided by 5. So 5 into 5 is 1. 5 into 35 is 7. All right? So it's beginning to look good, right? And as soon as 7 shows up, I notice there's a relationship between 7 and 42, right? From the times table, 7 times 6 is 42. So if I divide this by 7, I get a 1. If I divide 42 by 7, I get a 6. Now I'm free to multiply the tops and the bottoms. On top, I got 4 times 1, which is 4. At the bottom, I got 1 times 6 is equal to 6. Remember, you're only multiplying what is not crossed out, the final values that you've gotten after using the common factors to, you know, reduce the terms, right? And even right here at this point, there's still a relationship between these two. So 2 into 4 is what? 2. 2 into 6 is what? 3, right? So our final answer is 2 over 3, right? And you notice that I missed this over here, but it's still better because now this fraction is much smaller and easy to deal with than having 12 multiplied by 35, you know, a large number, and then you start all over trying to divide. And that actually wastes time. If you're taking an exam and you using that approach, you actually lose time, right? So try and use this method of simplifying as you go. All right. Now let's try and do division. Okay, with division, what you do is, let's say you are given 3 over 7 divided by 6 over 7, right? There's this code that some students, you know, showed me. It says keep change flip. So 3 things: keep, change, flip, right? So basically what you do is you keep the first fraction, right? So 3 over 7, you do nothing to it. And then you change the operator, which is a division, to multiplication, right? So you use the opposite of the operator. So it becomes multiplication, and then you flip the second fraction. Flipping means, you know, get the reciprocal of the fraction given. So basically it's going to become 7 over 6. Anytime you divide in fractions, this is what you have to do. The operator will change, and the second fraction will be the reciprocal of the original given fraction, right? So once we get this, we go through with the same approach I showed with multiplying fractions. We see 7, 7, that's easy to see, right? 7 into 7 is 1, 7 into 7 is 1. We see correlation between 3 and 6. 3 into 3 is 1. 3 into 6 is 2, right? We multiply the numerators to get our numerator. And then we multiply the denominators to get our denominator. So 3/7 divided by 6/7 gives us half, right? And the code is keep, change, flip. Keep the first fraction, change the operator from division to multiplication, and flip or find the reciprocal of the second fraction, right? That's easy to do. All right, let's do another example. So I'll do a second example here. Let's say we have 5 over 8 divided by 15 over 24. By using keep, change, flip, same thing. You keep the first fraction, 5 over 8. You change the operator to multiplication. As soon as you do that, you flip this second fraction. So it becomes 24 over 15. And then you go at it with, the common factor approach. Don't multiply 5 by 24 and then 8 by 15 and start to, simplify, right? Simplify the fractions as you see them. As long as it's multiplication, right? Just look at the numerators and see how they relate to the denominators. So I see a 5 here. 5 here is 1. 5 here is 3. I see 8 and 24. 8 here, I won't even waste time. But, you can start small. You can, 2, 2, 2, dividing by 2, 2, little by little. Baby steps until you get there. But here, if you know it, just do it, right? And then 8 into 24 is 3, right? And then I see a relationship here too, right? 3 into 3 is 1. 3 into 3 is 1. So in the end, when we multiply, we got 1 times 1, which is 1, over 1 times 1, which is 1. So this means that when you divide 5/8 by 15 over 24, your final result is 1, right? 1 over 1 is 1. All right? Thank you for listening in.